So welcome back guys. In this module we will going to discuss the application layer. So the application, the topmost layer of the TCP IP stack, and we will discuss how to implement our own application in the application layer of the TCP IP stack. So application layer is the topmost layer in the TCP IP stack or the OSI model. It is a layer at which the packet journey starts on sending machine and ends on destination machine. Application layer lies outside the operating system or kernel. So we have already discussed that the data link layer, the network layer and the transport layer are the part of the TCP IP stack, but application layer is not the part of TCP IP stack, but actually it resides on the top of the TCP IP stack. And all the three layers, that is the transport, network and data link layer, are the part of operating system, right? They run in the kernel mode. That is, they are implemented inside the operating system, whereas applications runs on the top of the operating system, right? Applications do not run in kernel mode. So the user space program that we write in our day-to-day life are all examples of applications. The TCP client server program that you wrote were also an example of application programs running in application layer of TCP IP stack, right? So whatever C programs that you have written so far are all examples of application programs. One network application program that you are using right now is the browser itself, which is making use of application layer protocol HTTP. So HTTP is a protocol which makes your browsing possible. The application program which you are using right now while browsing this course is the browser. So browser is an example of network application program. Other examples of network application programs that we have already discussed in this course is Icmp Protocol. So you remember the ping utility works on Icmp Protocol. So Icmp is an application layer protocol, and the application which is using Icmp Protocol is a ping application which is used to test the reachability of a certain IP address in the network. So in this module we will learn how to write our own application program which have its own application headers, right? So this is the goal of this module. So remember our old TCP IP stack, right? So we will going to see how to implement custom application protocol. That is, we will going to write our own application protocols. So just like other layers of TCP IP stack, our application protocol will also have its own application header. So you see that the transport layer protocol has their own headers like TCP header and UDP header. The IP layer protocol, that is the IP protocol, has its own header called IP header. And the data link layer protocol like ARP protocol or Ethernet protocol have their own headers, right? So we discussed that the ARP protocol has header which defines two types of messages, the ARP broadcast request and the ARP reply message, and the Ethernet protocol has its own header called Ethernet header, which encodes the destination and source MAC address and makes the L2 routing possible. So you can see that all the layers of the TCP IP stack have their own set of headers. Then why not the application layer have its own set of headers? So we will going to write an application protocol which will have its own set of header. So our application protocol will have its own sub messages type as well. For example, Icmp protocol has two types of sub messages, which is called Icmp echo request and Icmp echo reply. Similarly, the ARP protocol had two types of messages, the ARP broadcast request and the ARP reply message. Similarly, we will going to write our own application protocol which will have its own sub messages. So guys, there are three ways to implement your application protocol in TCP IP stack. Either you implement your application protocol on top of transport layer. This is one way of implementing application protocol. The second way of implementing application protocol is on the top of network layer in the TCP IP stack. The network layer is the IP layer. And the third way of implementing the application protocol is directly on top of the data link layer protocol. That is directly over the L2 layer of the TCP/IP stack. So let us try to understand what we mean when we say that you can implement application layer protocol on top of transport layer or network layer or data link layer protocol. Let us see what does that mean. So guys, let us discuss the scenario when application protocol is run on top of the transport layer protocol in the TCP/IP stack. So on the right hand side you can see the TCP/IP stack, which has three layers: the transport layer, IP layer and the data link layer. Right? So when I say that you can run your application protocol on the top of transport layer protocol, it means that you can run your application protocol here in the TCP/IP stack. That is, the application is running on top of the transport layer. Right? The underlying layer in this scenario below the application is the transport layer itself. So the example of one such application is the HTTP web server. So HTTP web server is an application protocol which runs at the application layer on top of the TCP protocol. Right? So when you run your application on the top of the transport layer protocol in the TCP/IP stack, it means the underlying protocol is the transport layer protocol, which could be UDP protocol or TCP protocol. Right? The two most commonly used transport layer protocols are UDP and TCP protocols. Application needs to listen on TCP or UDP port number. So when your transport layer will receive a packet, it has to identify that which application running above it is interested in that packet. Right? So transport layer identifies that using port numbers. So when you run the application on top of the transport layer protocol, the application needs to listen on a port number, which is TCP port number if the transport layer protocol is a TCP protocol being used, or it is a UDP port number if the transport layer protocol being used is a UDP protocol. So TCP and UDP protocol will take the responsibility for packet transmission between sending and receiving process. So sending process may be running somewhere on the sending machine in the network, and the receiving process may be running somewhere on the receiving machine in the network. So remember, the transport layer protocol is concerned with the transmission of the packet between sending and receiving processes. The network layer, on the other hand, will take the responsibility for packet transmission from source machine to destination machine. And finally, the data link layer will take the responsibility for packet transmission hop by hop in the network. So it means that all the underlying layers, that is the transport layer, the IP layer and the data link layer, will do their jobs as usual. So when your application is running on top of the transport layer in the TCP/IP stack, that is, your application is running in the application layer, the packet that is generated by the application will suppose to have the data link layer header, the IP header, the transport header, as well as the application header. So you can see, because your application is running at the application layer and all the layers of the TCP/IP stack are functioning as usual below the application layer, when the packet generated by the application traverses down the TCP/IP stack on the sending machine, all the layers in the TCP/IP stack will append their own headers to the packet. So the packet generated by applications running on top of the transport layer protocol will have MAC header, will have IP header, will have transport header, and will have its own application header. So the message somewhat looks like this. So you can see that the MAC header contains the destination MAC address as well as source MAC address. The type field contains the identifier which identifies the protocol running above the data link layer. So this is a constant value, which means 0800, and it means that the protocol running above the data link layer is the IP protocol, and IP protocol has its header called IP header. IP header has the source IP address, the destination IP address, and the protocol field of the IP header identifies the protocol running in the transport layer. So if the protocol field is 6, it means the transport layer protocol is TCP, and if the protocol value in the IP header is 17, it means that the transport layer protocol is UDP. So these are actually the reserved values, 6 for TCP and 17 for UDP, right? And then in the packet, there is a transport header which has the source port number and destination port number. It could be TCP header or it could be UDP header depending on the protocol value in the IP header. And finally, the last header in the packet is the application data. The application actual data is the last part of the packet. So you can see when the application runs on the top of the TCP IP stack, that is above the transport layer, the packet generated by the application will have headers corresponding to all the layers of the TCP IP stack. Right? So going forward, the second method of running the application is directly on top of the network layer in the TCP IP stack. So here in this diagram, you can see that you are running the application in the application layer, but your application layer is running on top of the IP layer. There is no transport layer. There is no transport layer. Right? So what does that mean? It means that when there is no transport layer protocol, it means there is no TCP or UDP protocol which is responsible for packet transmission from source process to destination process. Right? And when your application runs on the top of the IP layer, that is the network layer of the TCP IP stack, then your application has to define its own protocol value X. And this protocol value X will go in the protocol field of the IP header. So remember in the previous example, this value was either 6 or 17, depending whether the transport layer protocol is TCP or UDP. But since there is no transport layer right now, so the X value has to be defined by the application itself. So remember that every layer in the TCP IP stack has to encode some information to tell that what is the next layer running above it. So going by that principle, the IP layer has to provide the information to identify the application running in the application layer. So that identification is now done by the protocol field value, right? So let's say that if I define the protocol field value, say X is equal to 255, it means that your application layer protocol is assigned the protocol number 255. So any packet which comes with the IP header, which comes with the protocol value as 255 in the IP header, the receiving machine will going to hand over that packet to the application which corresponds to protocol number 255. Right? When we will be discussing the code to implement our own application protocol, then you will understand it better. So have patience. Network layer takes the responsibility for packet transmission from source machine to destination machine. So this is the basic job of the network layer. And network layer takes the responsibility to hand over the packet to the application based on the protocol field value X. So remember, when your application was running on the top of the transport layer in the previous scenario, the transport layer identified the correct application to which the packet has to be handed over. That application was identified using port number. But now there is no transport layer. So it is the responsibility of the IP layer to identify the correct application running in the application layer to which it can hand over the packet. So that correct application is identified using protocol value in the IP header of the packet, right? And as usual, data link layer takes the responsibility for packet transmission hop by hop. So you can see that there is no transport layer in this example because we are running our application directly on top of the IP layer protocol. There is no transport layer header in the packet. So the packet that is generated by such applications will have MAC header, will have IP header, and directly will have application header. There will be no transport header. Why there will be no transport header? Because the transport layer is not being used. As simple as that. So you can see here that when we run the application directly on the top of the IP layer, and when there is no transport layer, it means we cannot make use of any benefits that is provided by the transport layer protocols. For example, we have a TCP protocol which provides us several benefits. For example, recovery mechanism, right? For example, congestion control in the network. And there are other benefits that is provided by the TCP protocol. So since in this example we are not using transport layer protocol at all, therefore any of the benefits provided by the transport protocol cannot be harnessed by running application directly on top of the IP layer. So going forward, the third way that we can run our application protocol is directly on top of the data link layer protocol. So when we run our application directly on the top of the data link layer protocol, you can see that there is no transport layer protocol, there is no network layer either. And because there is no network layer, the packet can never be subjected to L3 routing. And data link layer takes the responsibility for packet transmission from source machine to destination machine. Remember, the source and destination machine have to be present in the same subnet, because data link layer cannot route the packet from source machine to destination machine present in different subnets. So data link layer is still doing its job. So all machines in the same subnet are neighbors of each other, hence data link layer is still doing its hop by hop work. So you can see that when you run an application on the top of the data link layer directly, there is no transport layer, there is no IP layer, and therefore the packet that is generated by such applications will not have IP header, will not have transport header. Now the question arises that when the application do not have IP header, it means the packet generated by the application do not have source IP addresses and destination IP addresses. So when the packet doesn't have its destination IP address, it means the packet doesn't know where it is going, right? Using the destination IP address field only, we find the destination machine in the network. But in this case, there is no IP header, it means there is no destination IP address. So where is actually packet going, right? So let us discuss this in a bit detail on the next slide. So yes, it is possible to have the packet without L3 header. So when sending machine A needs to send a packet to destination machine D, A already knows that D is in its own local subnet, right? So this type of packet can only be delivered from machine A to machine D, provided that the machine A and D are present in the same subnets. The reason is that the packet do not have IP header, and such a type of packets cannot be L3 routed between subnets. So remember L3 routing was done by L3 routers using IP header. So packet can be delivered to B using L2 routing alone. Sorry, it's not B, it's D. And when we say L2 routing, it means based on only MAC addresses. So when the source machine and destination machine are present in the same subnet, it is not compulsory to add IP header to the packet, right? But even if you add the IP header, there is no harm. There is no harm. But if you omit the IP header, then also there is no harm. So you can see in this diagram, suppose the machine A wants to send the packet to the machine C. You can see that the machine A and C both are present in the same subnet, right? So A can always send the packet to the machine C using L2 routing only. And that is the reason that in order to send the packet from machine A to machine C, the only required thing is the MAC header. Because MAC header will contain the destination MAC address, which will identify the machine C and the source MAC address. So when the source machine and destination machine are present in the same subnet, there is no need for the packet to ever cross the L3 router boundary. And therefore there is no need for the IP header in the packet. So that is the reason when it is pre-decided that the destination machine of the packet is in the same subnet, you can always generate a packet with only MAC header and the application header. So in this example, the source MAC address is MA, that is the MAC address of the source machine A, and the destination MAC address is the MAC address of the machine D, that is D is the destination. So both the machines, that is A and D, are present in the same subnet. So they can communicate and exchange data with each other with packets having only MAC headers.